All right, so yesterday I talked to you guys about the first and second and third differences, where if you have a table of stuff and then you subtract the y values, if those are all the same, then it's linear. If they're not and you do it again and then those are all the same, the second differences are the same, that would mean that it's quadratic, degree 2. If the third difference is all the same, it's cubic, degree 3, etc. And so what they want to do right now is they want us to prove that. The first thing we're going to do is we're going to use a regular cubic equation that they gave us to make a table of values and then show that the third differences are the same. And then the second thing, hey Joe, that we're going to do is, thanks, uber cray cray, we're going to take the general cubic function and show that those third differences are the same. So we're going to prove that it's true for any one, not just a specific one. Well, let's do the specific one first. Does anyone have their book open or whatever, the x cubed minus 3x squared? So I can go to Desmos and type it in and you guys will tell me what it is. Oh. What class is this? Okay, so let me, all right. So what I want to do is I want to make a function on Desmos. Whoops. And what is that function? Yeah. Okay, minus 3x squared. Just that? Okay. So we got to pick like 5 numbers and plug them in there to make our table. You want to do 1, 2, 3, 4, 5? Such as said. All right. So let's do f of 1 first. And if I plug 1 into there, then I get negative 10. So what I'm doing here is I'm making a little table. Here's x. Here's f of x. 1 gives me negative 10. Then if I change that to 2, I get negative 14. If I change that to 3, then I get, negative 12. Then if I change it to 4, I get 2. And finally, if I change it to 5, I get 34. Whoa. Okay, so that was just me using Desmos to create a table of values. What we're going to do now is we're going to show that the third differences of those are the same because it is x cubed. So what did I do to get from negative 10 to negative 14? Minus 4. How about negative 14 to negative 12? Plus 2. From negative 12 to 2 is plus 14. And from 2 to 34 is plus 32. Okay, so those are the first differences. Those are not all the same because it's not a linear function. How about from negative 4 to 2? Plus 6. How about from 2 to 14? Plus 12. And how about from 14 to 32? Plus 18. Okay, those are the second differences. Those are also not the same because it's not a squared. But look at what happens when we do this a third time. Then we get plus 6 there, and we get plus 6 there. Okay? Everything okay? Yep. Yep. If you wanted to, you could use this to figure out what you would get if you put in 6. And that's what number 54 wanted you to do. You could work backwards a little bit. What would this number be right here? What would this number be here? 24. So if that's plus 24, then that means that this would be plus 56. And if that's plus 56, that means that if I plug in 6, I would get 90. Okay? I do, kind of. I mean, I feel pretty good about it, but yeah. All right, does that make sense? Okay. All right, the next thing that they want us to do is pretty crazy stuff. And you shouldn't get like freaked out if you don't know what the heck is happening in just a second here. But what they want us to do is, instead of using specific numbers, let's just plug in numbers to the general thingy. Yeah. Uh-huh. Uh-huh. I recorded the lessons a couple times and emailed them to your student email. Did you check your student email? Yeah, go ahead and check right now. You should have got it from, yeah. Check and see, and if you don't have them, I don't think I did Thursday. But I feel like I did Friday and yesterday. I know I did yesterday. Yeah, it's all right. Okay, Kate, are you ready? Okay. Yeah, go ahead. Uh-huh. Let's go to 4. 5 numbers seem to get it done, okay? All right, if I plug 0 into here for x, what do I get? Nope. Yeah, because this would be 0, this would be 0, this would be 0, but this does not have an x in it, so that would stay there, okay? What do I get if I plug 1 into there? Yeah, but the x's are now 1s. So, yep, it would be a plus b plus c plus d. Okay? What do I get if I plug 2 into here? What's 2 cubed? 8, so that would be 8a plus 2 squared is 4b plus 2c plus d. Okay? What do I get if I plug 3 into there? What's 3 cubed? 27. So 27a plus 9b plus 3c plus plain old d. And then what's 4 cubed? 64. So 64a plus 16b plus 4c plus d. Okay? All right, so now what we're going to do is we're going to figure out the differences with these. And things are going to get a little crazy when we do that, but before we do, let's talk about what we're really doing here. To figure out that this was -4, what I was doing is I was going this number minus this number, okay? This number minus the one before it. So if I go a plus b plus c plus d minus d, what do I get? A plus b plus c. And then if I go this one minus this one, 8a minus a is 7a, 4b minus b is 3b, 2c minus c is c, and then those cancel. Okay? You guys kind of, a little bit? Yeah, okay, Aaron gave me the Okay, 27a minus 8a is 19a. 9b minus, yep, thank you. I asked if you were ready. You said you were. You did not lie. How about the next one? 64 minus 27? 37. Well played, sir. Hey, Cap. So 37a plus 7b plus 1c. Okay, so these are the first differences. Are they the same? No. So let's go around again. All right. So if I go this, all right. So that gives me 6a plus 2b. This one would give me 12a plus 2b. And then this one is 18a plus 2b. Are the second differences the same? Hi, Elena. Yeah, give me just one quick second. Almost done. All right, so these are not the same. If we go one more time, then I get 6a. And then right here I get 6a. And so what we just showed is that no matter what your starting numbers, because we just picked variables for that, if it's a cubic, when you do the third differences, they all come out to be the same. Okay? Okay, go for it. Anybody else have any other questions from this? Okay, so moving on. Uh-oh. Okay. So moving on, in the next section we're going to talk about factoring polynomials. So yeah, thank you for that enthusiastic response. So we've already talked about factoring quadratics. Now we're going to factor polynomials. So we're not just going to stop at x squared. We're going to do some x cubed stuff also. All right. So, for example, what is the factored form of x cubed minus 2x squared minus 15x? What do you notice that we can, what can we take out of each one of those terms? What do they all have in common? Yeah. Okay, good. So since we already know how to factor quadratics, if we can take a trinomial, if we can take, a cubic and turn it into a quadratic by factoring out an x, then we are off to a great start. And so that's what Max did. He factored an x out of each one of those terms, left us with x squared minus 2x minus 15. Now we can factor this. Two numbers that multiply together to be negative 15 and add to be negative 2 are negative 5 and positive 3. Good. So that in factored form is x times x minus 5 times x plus 3. All right? So just one little extra step added on to what you guys were doing before with quadratics. Okay? Patel. Okay, questions on that? He's a graph paper kid, yeah. Bless you. All right, will you guys take a quick second to factor that one on your own? So starting with x cubed minus x squared minus 12x, and let's factor that as far down as you can get it. Okay, Jimmy, what'd you come up with?
I got the x.
Okay, x parentheses x squared minus x minus 12. Yep, that's a good start. Okay. Is that as far as you got, Chief? Okay, you can do better than that. Two numbers that multiply together to be negative 12 and add to be negative 1. Negative 4 and 3. Okay, so x minus 4, x plus 3. Okay, you right. Okay, makes sense? All right. Okay. So, yeah. Okay, you did what now? Because you factored out a negative x? But why? Oh, okay, so you're just like changing the problem to make it more. Okay, so if you, let's see what happens. So you made it like this, and then did you keep the rest negative? Okay, and so then you factored out a positive x still? Okay, and that left you negative x squared minus x minus 12. Okay, in order to factor this, you need to factor out a negative. Yep, so make that negative x, and then this would be x squared plus x plus 12. And then now you can factor this into two numbers that multiply together to be oh, but you can't do this. So this would not factor. Because there's no two numbers that multiply together to be positive 12 and add to be 1. Out in front? Right here. You were right here. Okay. It still won't work though, because in order to factor it from here, did you go like that? Yeah. Okay, and then what two numbers did you use? negative 4 and positive 3. But if you FOIL this out, the negative x times the x does give you the negative x squared, but then this would be negative 4x in the middle and negative 3x on the outside, which would give you negative 7x. So the way that you have written it is not factorable, okay? Which is a good point. What would you do if you got to this point right here and we couldn't factor it? What's another way that you can solve that? The quadratic formula, yeah. So not all of these will be factorable. Sometimes you have to use the quadratic formula, but you can always use that if you need to, okay? That's why it's so handy. All right, so the one that we did together that did factor, we factored into x times x minus 4 times x plus 3. Lots of stuff going on here, okay? Here's one thing. The first bullet, it says x minus b is a linear factor of the polynomial. So these are called linear factors, okay? Because we broke it down into some stuff that's all to the first power. Then if I were to set this equal to 0, what would x have to be to make it equal 0? 0. What would x have to be here to make it equal 0? 4, because 4 minus 4 is 0. And what would x have to be? Negative 3. Okay, so these are called linear factors. When you switch the sign, when you set it equal to 0, those are also called the zeros of the polynomial because you get them by setting the polynomial equal to 0. These are also called roots of the equation, okay? And they also, these will be the x-intercepts of the graph, okay? So a lot of stuff going on there, a lot of information you get when you factor a polynomial. You know what the zeros are, you know what the roots are, those are the same thing. And then you also are given the x-intercepts of the graph, okay? Exciting stuff. All right, so if you are given it already in factored form, what are the zeros of x plus 2 times x minus 1 times x minus 3? What values of x will make each one of those parentheses equal to 0? Don't all answer at once. Appreciate you all want to participate and show off your knowledge, but we got to negative 2, because if I plug negative 2 into here for x, then that'll make that 0. Then she said 1, because 1 minus 1 is 0. And then also 3, right? Because 3 minus 3 are 0. Okay, so now we can make a rough sketch of the graph without using Desmos. Because those are not only zeros of the function, those also tell you where the graph crosses the x-axis, okay? So you know it's going to go through those 3 points. So to do that, I have two choices. I can either look like this, or I can look like this. How can you use something that we learned yesterday to figure out whether it's the purple graph or the blue graph? Exactly, the up, 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 down, positive, even thing. So if I were to FOIL this out, I only have to worry about the biggest term. X times x times x would be what? X cubed. Okay, so that's my first term. That's my highest thing. Is the degree even or odd? The degree is odd. Is the lead coefficient positive or negative? Okay, so what does odd positive do? Down, up. So is it the purple or the blue? It is the purple. Hey. It would be the purple graph that would be an approximation of the graph itself. Okay? And then the only other missing piece that I could use to sort of clean that up a little bit . Oh, right. Sorry. Yeah. Well, now there's only one there, so you don't have to worry about it. I can also find the y-intercept of this graph by multiplying these three numbers together. So 2 times -1 is -2, times -3 is 6. So that means that this y-intercept would be 6. Okay? Do you want to see that live and in action on Desmos? Not so much? Trust me? Not really. You know, maybe if you want to like, but if you trust me, you're good? All right. Okay. So what are the zeros of this graph? Let's aa1. What are the zeros of this graph? What value of x makes this 0? X. Yeah. Yeah. 0. Okay. What value of x makes this stuff 0? +3. Awesome. And what value of x makes this 0? -5. Okay, so those are the zeros of the function. Now let's use those to make a rough sketch of the graph. So I know it's going to cross the x-axis at 0 and at 3 and at 1, 2, 3, 4, -5. Okay, is this going to be, what's the end behavior of this graph if I were to FOIL it all the way out? What's the lead term in this thingy again? Yeah, this would also be a down up because it is going to be an x cubed, and so that means that our graph would look something like this. What's the y-intercept? You're right, man, it's 0. Okay? All right, we can go backwards. If they tell us what the zeros are, we can use those to write the function. If you know the zeros are -2, 2, and 3, then what has to be in the parentheses? Yeah. X plus 2. Good. So please understand that these numbers here in the parentheses are the opposite of these numbers here. Okay? So we had a -2, so Max made this a +2. We had a +2, so Max made that a -2. And we had a 3, so we made that a -3. Okay? So that should be pretty simple. And what about this one? Okay, right. X plus 2, x plus 2, x minus 2, and x minus 3. Okay, now this x plus 2 comes up twice. Awesome. So that is x plus 2 squared. And that is going to affect the graph a little bit, because how do I go through -2 on the x-axis twice? And so that is where we are going to take up our conversation tomorrow. Okay? So for right now, I'll just give you a few of these to work on what we've done so far, and then we will talk about multiple zeros of functions tomorrow.